Always.
Okay. So I'm introducing a new unit. We've just finished our attendance. This is beginning of class. I'm starting the unit off fresh. So we are going to talk in this unit about freshwater and saltwater systems. This is grade 8 science. I wanted to start off today, guys, by talking a little bit about the typhoon that happened in Japan just a few days ago. So typhoons, or hurricanes as they're called here. Do you guys know what the difference is between a typhoon and a hurricane?
Negative.
Honestly,
Negative.
no.
Any guesses? Yeah.
Is typhoon happen in certain oceans and hurricanes happen in the other oceans? I don't
Bingo.
know.
Thank you, Eric. You're exactly right. Typhoons occur in the West Pacific. Hurricanes happen in the North Atlantic. That is the only difference. They're the exact same storm. That is it. So Japan says Typhoon Hagibis triggered floods and landslides as it battered the country with winds of speeds up to 225 kilometers an hour. Rivers breached their banks in 14 different places. Storm led to some Rugby World Cup canceling, which really disappoints me. I'm a big rugby fan. It made landfall, blah, blah, blah. So, big storm caused a lot of damage. So we've got some images of the damage here, and a map of generally where it hit, and it came across and went north like that. So, people killed. Why are hurricanes and typhoons such a big concern? Eric?
Because people are killed.
Because people are killed. So what causes the damage? Yeah, bro.
I was gonna say we're getting more because of climate change.
Absolutely. Absolutely. I'm gonna bring my computer up here real quick, guys. So, what technology do we use nowadays to track hurricanes and typhoons, or to track weather?
Satellites?
Yeah, use satellite imaging. There's a lot of technology nowadays that helps us to recognize when there's going to be storms. Okay, what is it about the storms? What is it about the storms that causes so much damage?
We have
Yes.
a lot of rain and wind.
Rain and wind, absolutely. So, wind coming from this way is going to create what do you guys think? What's this? What's this whole section right here?
Water.
Yay, water! Thank you. So it's water. So wind creates waves a lot of the time. We're going to talk first today about waves and tides and how those are formed. So water is the primary focus of this unit. So what are the three states of matter that water can form into?
Solid.
Solid, another one,
Liquid.
liquid,
Gas.
and gas. So hurricanes are formed of what type, what state of matter? What state of matter is a hurricane in with the water?
Liquid? Like what?
Liquid. Yes, you're all wrong. Universally wrong. It's in a gas. It's a cloud, right?
Oh.
Big cloud, lots of wind. That's okay. We're learning. Okay, where does water accumulate in its solid form?
Near the poles.
Near the poles, exactly. Glaciers, things like that. So these are things that we're going to touch on a little bit more further into the unit, but I wanted you guys to keep that in mind. So I want to look at tides. So does a hurricane cause the tide?
No.
No, you're exactly right. What does impact the tide? Yeah,
The moon.
the moon. Yes, bingo. What is it about the moon that's causing the tides to change?
I don't know.
Gravity.
Gravity, there we go. So we've got the gravity of the moon, but we've also got the influence of the sun's gravity that is impacting how tides happen. So, currents are things in the ocean. Currents are the movements of water in the ocean that can change how our tides move. So currents, sorry, I'm making a mistake there. Currents are the movement of water through the ocean based on temperature typically. So they shift around, they go up and down, they circulate up and down in the water, but they also circulate around the ocean in huge, vast areas. So what let's go on with tides. Where's my markers? I'll get you to turn around. I'm gonna steal your markers, and you can get off your phone and focus a little bit. That's okay. That's okay. I'm not gonna judge. Okay, so we're gonna talk about tides. So we've got the gravity from the moon and the gravity from the sun affecting Earth. So here we have our Earth. We're not gonna care about poles. We're not going to care about direction, but we're going to say it's a top-down view of the Earth. So that's a pole on the Earth. And so we've got, I'll use red for water because I don't have blue. But let's say we have the moon over here, pulling on the water. So what happens with the water, if it's all the way around the world, is it pulls slightly up or bulges as it faces the moon, as the moon passes above. What do you guys think is happening on this side of the world with the water? Closer or further from the Earth's surface?
Closer.
Closer? So it would look like this. Right? Right? Wrong!
Oh.
It gets what's called a sympathetic bulge. So we actually get something like this on the opposite side of the world. That's real bad drawing. So big, but we get a sympathetic bulge on the opposite side of the world. Let's say we add the sun into the equation, okay? So the sun is much further away, but its mass is much, much greater than that of the moon. What's mass, guys? We've talked about it before. Think about density. What is density?
Mass over volume.
Mass over volume. So density is how much material there is in a certain specific space. Okay, so the sun is really big with a lot of matter compacted into a small space, or a big space, I guess. But really dense, a lot of material, has a massive gravitational pull. Okay, so let's say we put the sun over here. Yeah, here's the sun. What's going to happen to these tides? What do you think is going to happen?
More sympathetic bulges.
You're absolutely right. So we get even further expansion of these tides. Okay, so the water pulls up in the ocean even further. So we've got the moon and the sun on opposite sides of the planet, and that affects the tide to increase its tidal flow. Okay? Same thing if we get the sun over here. Right? We get rid of the sun here, and it's behind the moon, it's going to cause the exact same thing. Let's say we get rid of the sun over here. Earth's rotating, moon's rotating around the Earth, and the sun is down here. What are the tides going to look like? I don't have a big eraser. That kind of sucks. Does somebody want to come up and draw their guess of what they think the tides might look like?
If what happens, sorry?
If here's the sun, and there's the moon. What do you guys think the tides are going to look like? I'm going to take a gander at it, Travis. Thank you.
Why not? Just don't yell no at me and screw up.
Oh, I always yell no.
Do you want me to do 2 circles? Just one.
One's good. One's good. I like that. I think that is a pretty reasonable guess based on our understanding of angles and how things pull on each other. But unfortunately, he's wrong. He's got a good idea, but it's not quite correct. So, when we have the sun and the moon, let's go back to this example here. We've got the sun and the moon on opposite sides, or the sun and the moon on the same side, with that extra big swell. This is what's called, if I'm remembering correctly, a spring tide. So a spring tide is when the water springs further in that bulge. It has nothing to do with the seasons. Okay? Just remember that. Spring tide has nothing to do with seasons. So, tide, a very key word for our lesson. What happens when the sun is down here, opposite or perpendicular to the moon kind of thing, we've got a pull in this direction and a pull in this direction. And so what happens is you get a relatively even pull around the world. You don't get a big tide. And this is what's called a neap tide. So the tide is at its lowest point pretty much everywhere on the planet at this point. And you get sun and moon perpendicular to each other. Yeah.
How often would that happen? Is that like a daily occurrence, or?
So let's think about this. How often does it take the moon, how long does it take the moon to travel around Earth? I'll give you a clue. Women have a monthly problem that takes about the same amount of time.
28 days.
28 days. Biology lines up with the moon, unfortunately. So I'm not going to go into that any further. So we'll get me in trouble. But that's the case. Every 28 days, you get changes in these fluctuations. On a daily basis, a tide changes twice a day. But it's not exactly on a 24-hour schedule. The moon rotates around the Earth on roughly 24 hours and 50 minutes. So it's not exactly perfect. There will be some days of the month where you will only have one tide in a day, where the second tide of the day will only, so remembering that we're getting this bulge here from the moon and on the opposite side of the planet. So it's morning here, we're standing here, or it's lunchtime, and our high tide is here. Lunchtime, and then again, we're going to get, when the moon is here, we're going to get the same thing, high tide, a short while later, at the opposite end of the day, okay? So then 24-hour period, you're getting that tide twice, generally, is the case, okay? So when the moon is here, and here, we're going to get a high tide. You guys understand? Questions? No? So, neap tide, you've got a spring tide, and a neap tide. Neap tide being the lowest point when you have the sun here and the moon here. And there's not a huge change in the tide. Okay? Time frame?
You're at 12 minutes.
Okay, so we're going to go from our tides and we're going to look at how these waves and tides might be impacting cliff formation. So, okay, no eraser. This is so much fun. So, have you guys seen some images of cliffs before? Oceanic cliffs?
Yes.
Yes? Can I get 3 people to come up and draw a couple of cliff formations? One cliff formation that you've seen. Tell me one. If you've seen a cliff formation on the ocean, what does it look like?
More or whatever?
Yeah, what do they look like? Come up and draw roughly what it looks like. Doesn't have to be perfect, just a rough idea.
What kind of view do you want?
A side view. So you're standing on the water, you're on a boat, you're looking at the cliff, or you're like on the beach looking along the cliff. What does it look like from the side?
Not a very good drawer, but.
Beautiful.
Right?
Beautiful.
Cliff.
Awesome.
Land.
Okay. We've got the cliffs of Moher.
That's really good.
Anyone else? Cliff ideas, things they've seen. Anyone been to Hawaii? It's friggin' awesome. You should go. Yeah.
I don't know what they're called, but they're in the UK. So like, has anybody seen Broadchurch?
Is it the Cliffs
The
of
show?
Dover?
Yeah, maybe.
Yes.
Yeah, the show
Cliffs of
Broadchurch.
Dover. Yep.
It's just like the beach. That's all I got.
Okay, perfect. We'll pretend that this is water down here.
That's actually the beach.
30
That's the beach?
seconds.
Yeah,
Okay.
that is the water.
Okay, so we've got some beach, so we'll draw like this.
Matt, you have 20 seconds.
Okay. Well, that's okay. I would do a review to wrap up my class. I would cover tides. I would further in my lesson. I would cover how waves impact formation of beaches and coastal areas in general. I would touch on rivers systems, and I would look at braided rivers, straight rivers, and meandering rivers, and how those form, and the types of earth that they're running through, how dense the sediment is, how well packed it is. And then, like I said, I would do a review. I would cover some of the vocabulary words that I would have gone through this lesson, and have you guys write down the key vocabulary words, and then remark on which ones might be on a quiz. So that is my lesson. Thank you.
Awesome.
Great job.